We're now at Algebra 2 10.4d, and we're going to talk about how to graph a hyperbola by completing the square, and I have a theorem for you. We have 14 previous videos now for Chapter 10. If you become lost or confused, just click in the description and find out where you got lost. If the center of a hyperbola is not at the origin, but at some point h and k, then we have a different standard form of an equation than when it's centered at the origin, like we saw in one of the previous videos. So here's my theorem for you. The equation in standard form of a hyperbola centered at h and k with the foci c units from h and k is the quotient of the square of x minus h and a squared minus the quotient of the square of y minus k and b squared equals 1. That's if it's a horizontal foci. Or we could swap places with the square of y minus k and have it over the a like this, and that would give us a vertical foci. And that's where c squared equals a squared plus b squared. You might want to freeze the frame and write that down, because my theorems can be very helpful. All right? It's good to have these equations written down. Now, we swapped places with the square of y minus k, didn't we? Well, if we swap places with the y squared, these are actually conjugate hyperbolas, and if they're graphed on the same axis, they'll have the same asymptotes. We can find the center, vertices, foci, and asymptotes, and then graph the hyperbola of this equation. First thing we're going to do is we're going to add a negative 28 to each side to set it to equal negative 28 and get rid of that 0. Then we need to complete the square to find the standard form. So I now have it factored as 4 times x squared plus 6x because of that 24. 4 times 6 is 24. Here's the empty space where we need to complete the square. And we've got minus a y squared minus a 4y, because when we distribute that negative, we're going to get a positive 4y, right? And that's got an empty space for completing the square, and it equals negative 28. We take this term right here, we divide it in half to a 3. Then we square it, and we got plus 9. Now, because we put 4 times 9 on this side of the equation, we have to put it on that side of the equation to keep it balanced. Now, we take half of this negative 4, and that's a negative 2. We square it. Negative 2 times negative 2 is a positive 4. And there's an invisible 1 here, isn't there? And because we put minus a 1 times 4 on this side, we need to do it on this side of the equation. We combine all these like terms and get a negative 28 plus a 36 minus a 4. That gives us a positive 4. So now this is our equation. And we can factor this further, can't we? We can make this as 4 times the square of x plus 3 minus the square of y minus 2 equals 4. But we need it to look like this, so we need to set it to equal a 1. So we multiply every single term by the reciprocal of this 4, which is a 1/4. That gives us 4 over 4, which is a 1. Then on this side, it gives us a 4 over 4, which is a 1. And it gives us the square of y minus 2 over 4 for this one. We've got it set to equal 1. Now, you see this is a plus 3? It's supposed to be a minus, because that 3 is our h. So we can say it's minus a negative 3 instead of that plus 3. See? Now we know our center is a negative 3 and a 2. That wasn't that bad, was it? All right, so stick with me here. We've got this from our theorem, and we've got a 1 and a 4 as our denominators equaling 1. So we know A is a 1 and B is a 2, because that would be 2 squared, wouldn't it, to be the B squared? And the vertices of the hyperbola are now 1 and 0, see? And a negative 1 and 0. And c squared equals a squared plus b squared. That's the 1 squared plus 2 squared. See, that's how we got the 4. We can take away that little 2 exponent and put a radical sign around this side, can't we? It's going to be plus or minus the square of 1 squared plus 2 squared, which is going to be plus or minus the square of 1 plus 4, which is going to be plus or minus the square root of 5. So now we know our foci are the square root of 5 and 0 and negative square root of 5, or the inverse of square root of 5 and 0. See? Now to find the equations of our asymptotes, we can either do like we did in video 10.4b and just cut to the chase and do it really quick. It was y equals plus or minus b over ax. Well, we know b is 2 and a is 1, so that would be plus or minus 2 over 1x, wouldn't it? So our asymptotes would be y equals 2x and y equals negative 2x. We could also do it this way and find the equations of it. We change the 1 that it equals to a 0. Then we use the addition property to set the two fractions equal to one another. So this is minus. If I added this entire thing to both sides of the equation with the addition property, we would end up having it as a positive on that side of the equal sign, wouldn't we? So we would end up with this. And then we take the square root of each side, we put a radical sign around each one, and that'll get rid of that little 2 exponent, won't it? So now we've got the quotient of x minus a negative 3 over and 1 equals plus or minus the quotient of y minus 2 and 4. We can multiply each side by 4 to get the equations of the asymptotes. This is going to give us a 4x plus 12. This is going to give us a 4y minus 8, which is really a y minus 2, isn't it? Okay, and this is a 2 times x plus 3 when it's factored. So now these are our equations, see? We could just do it the easy route and do it that way like in video 10.4b, okay? So we know those are our asymptotes. Now imagine we're translating the center of the hyperbola from the origin to this negative 3, 2. So it's moving from 0, 0 to this negative 3, 2. So we've got to move it over to negative 3 and then up to the 2, don't we, for our HK values? Now, because it's a minus 3 and our vertices were a 1 and a negative 1, remember? They were a 1 and a negative 1. What we're going to do is we're going to say minus 3 plus that 1, and then our y value is 2, and minus 3 minus 1, and our y value is 2. And remember our foci was square root of 5 and negative square root of 5. Now it's going to be minus 3 plus the square root of 5 and minus 3 minus the square root of 5. See? With 2 as our y value. Now our asymptotes are y equals 2x and y equals negative 2x. Well, we know that in slope-intercept, this is the slope, isn't it? So we've got a 2 over 1 for our rise over our run. So we know the slope of our asymptote is going to be a 2 over a 1. So that's going to be our slant. And it's going to be negative 2 over 1. Remember when the slope is a negative, it goes downward. Okay, we learned that in 7th and 8th grade from my videos. We know our center is a negative 3 and a 2. We can graph this now. We draw our center line right here at our negative 3 and 2. We draw our asymptotes with the correct slope. Now we can just draw the hyperbola in, using the vertices as a guideline and the asymptotes as a guideline. See? Now, our next video, 10.4e, we're going to talk about asymptotes on the coordinate axis. I'm going to add this to the Algebra 2 playlist. There's going to be links to those previous 14 videos from this chapter. There's also going to be links to a few pre-calculus videos that talk about rational functions and finding the asymptotes in case you need that. All right? A lot of asymptote videos, all right? And I hope they're helpful. Hit the like button if they are. I hope you're doing great, and I hope you have a great day. See you next video. Bye.